In this video, we'll look at integrals of symmetric functions. If f is even, that is, if f of negative x equals f of positive x, then the integral from negative a to positive a of f of x dx we can rewrite as 2 times the integral from 0 to a of f of x dx. And if f is an odd function, that is, if f of negative x equals negative f of x, then the integral from negative a to positive a of f of x dx is simply 0. For example, notice that the limits on this function are opposites of each other, so we may be able to use one of the shortcuts. Let's see if this function is even or odd. So f of negative x. We'll go through and replace all of the x's with negative x. In the first term, we get negative x cubed. And then we get plus positive x to the fourth. And tangent is an odd function, so we can pull a negative out of that. This gives us negative x cubed minus x to the fourth, tangent x. And we can pull a negative out of both of those terms. And recognize that this is negative f of x. Since we started with f of negative x and got negative f of x out of that, we know that this is an odd function, therefore the integral is 0. In this example, notice that the lower and upper limits are opposites of each other, so we can question whether or not our function is even or odd. In this case, it's fairly obviously even because the degree on each of those terms is even. And so we can rewrite this as 2 times the integral from 0 to 2 of x squared plus x to the fourth dx. Now integrating, we get 1/3 x to the third plus 1/5 x to the fifth, and we're integrating from 0 to 2. Let's plug in our upper limit. We have 2 times 1/3 2 cubed plus 1/5 times 2 to the fifth, and then we'll subtract 0. When we plug in our lower limit, both terms go to 0. So this gives us 272 over 15.